are very small. Now I am giving energy to the first particle. When I give energy to the first particle, his amplitude increases, collides with the second particle. Now energy is transferring. So he will come back to the original state. Now his amplitude increases, collides with the third particle. Again he will come back to the original state. Now third particle increases the energy and collides with the fourth particle, transfers the energy. Again he will come back to the original state. Now who is possessing energy? Fourth particle. So his amplitude increases, collides with the fifth particle. Once the collision has taken place, again he will come back to the original state. Now fifth particle collides with the sixth particle. So finally now where is the energy? Sixth particle. To whom I have given? First particle. So how the energy transfer is taking place? From one to other in the form of collision. There, the increasing of the amplitude plays an important role. That's why vibratory motion play an important role in the energy transfer. So once energy is given to the first particle, his amplitude increases, gives energy to second. His amplitude increases, gives energy to third. It is just like our relay competition. In the relay competition, who is the winner? Either the person or the stick. Person or the stick? Stick. It is the stick. It is the stick. Whoever has carried that stick, they are all the winners. But ultimately the winner is the stick. Now the energy is like a stick here. Until the energy is with the first particle, importance is the first particle. Once it transfers energy to the second particle, it will come back to the original position. Now who is possessing the stick? Second particle. He is having is important. Once he collides with the third particle, it will come back. That's why in the relay competition, to whom we will encourage? To whom we will encourage? Whoever is possessing the stick. When the first person gives stick to the second person, will we encourage first person? No. We encourage second person. So who is important there? The stick. But not only the stick, the person who is carrying the stick. Similarly, when the energy is transferring, we give importance to that particle who is having energy. And when he transfers the energy to the next particle, this person will give importance. So, what is important here? Energy only, but not simply energy. The person carrying the energy is important. Okay? Activity just yes, beautiful. Now, this is how the wave propagation is taking place. So, in the wave propagation, yesterday we told the concept of phase. Just have a revision of this once again. Now you observe, when first particle is giving energy to the second particle, third particle is giving energy to the fourth phase. Similarly, this and this are in the same phase. So that's why these are the two particles which are the same phase successively. Therefore, the distance between these two particles we call it as wavelength. And the time period, the time taken for the energy to travel from here to here, we call it as time period. Am I right or not? So, we understood what is a phase. It's a behavior. How the first particle is behaving. In the same way, third particle is behaving. That's why 1 and 3 are in same phase, which are in successive. So, the distance between them is the wavelength and the time taken is the time period. Is it clear? Is it clear? Now come to the equation of the wave. Let us once again repeat the activity. Let us try to understand what is the equation of the wave. Once again. Oh, now energy, first time energy is with this void. Now the equation of the wave is nothing but writing the displacement of this particle. Okay. Now in order to write his displacement, as we know the energy has travelled from here to here. Suppose the energy, the distance that is travelled by the energy is x. After the time taken of t seconds, now I have to write his displacement in terms of x and t. I have to write his displacement in terms of x comma t. That's why we have written an equation that y equals to f of x comma t. That means y represents the displacement of the particle who is possessing energy at that instant of time. After t seconds, who is possessing energy? This particle. So, writing his displacement, because he is in the vibratory state, writing his displacement in terms of the position x and in terms of the time taken, then I can get an equation. That equation we can consider as the equation of the wave. Now, how to write that? This is an important aspect. As this particle is in a vibratory state, so can I take the equation of vibration? I can take the use of vibration. Now, what is the equation of vibration? Y equals to A into sine of omega t. This is the equation of vibration. Am I right or not? Now, I have to modify this equation so that it should become the equation of the wave. As I told, wave generation is because of the oscillations. Therefore, the wave equation also will come with the help of oscillations only. Now, I want to write the equation of the wave in the same way. In the same way means, as I want to write his displacement, let his displacement is y. Now I have to include the function of x and t. Am I right or not? Because the function, this displacement is depending on two variables, x and t. That x and t I have to keep in the equation. How? The standard form of the equation is same, but I have to include. How to include them? How to include is not actually the derivation, only through logical understanding we can understand. So I can write in a simple way. The general equation of the wave is y equals to a into sine of some angle theta. I will write some angle theta, because whatever I write within that sine, it should be in an angle. Sine is defined only for an angle. Now I have to modify all my variables in terms of theta. I have to understand what is this theta. Now remember, whatever is within that defined with respect to the angle, whatever I have taken as a function of sine, this total which is present in theta, which the theta represents, we call it as argument. Argument is nothing but the angle for which we are defining the theta. In general, we are calling this as an angle. According to physics, whatever this theta represents, it is called as argument. So, now we have reached a stage where I have to define theta such that I should include these variables x and t. Am I right or not? Because y is depending on x comma t. So, as y is the function of x comma t, I should represent x comma t somehow in this equation. Then that becomes the equation of the wave. How? The next question is how. Are you following? Okay. Let us try to understand this.